Alright, so this is lesson 3 in chapter 1. It's about multiplying and dividing rules for exponents. So our first one we're looking at is 2 to the 4th power times 3 to the 3rd power. Remember, in the last lesson we learned what the base is. The base is the number that's going to be repeating each time, where the exponent says how many times that base repeats. So in this case the base is 2. And if you're looking at this first one, that 2 to the 4th really means we're doing 2 times 2 times 2 times 2. And that 2 to the 3rd really means we're doing 2 times 2 times 2. So that would end up then giving us, if you look at all of them together, and you think this really is saying 2 times 2 times 2 times 2 times 2 times 2 times 2, that's really giving us 2 to the 7th power. Okay. On the next one, it's asking what is our base. Now, you have to understand that this is not our base. This is a coefficient. Coefficients are numbers in front of the variables. In this case, this was not a coefficient because there is no variable there, and this is being raised to the power. 3 is not being raised to the 4th power here, just the x is, okay? So x is our base in this case. And what this expression really means is we have 3 times x to the 4th power is 4 x's. Then we're multiplying it by, and on this one, this really has a coefficient as well. So when you're looking at this, the number in front of the variable on this one was 3. The number in front of this one is -1, really. So it's really like -1 times x. So when we put all of that together, we really have 3 times -1 is -3. And we have all of our bases there. So it's really x times x times x times x times x, which would be x to the 5th power. It's repeating that x 5 times. So if you're thinking about this, when we are multiplying either means you're using it with the dot or with parentheses right next to each other. That means we're multiplying them. The multiplying rule is going to be keep our base, keep the base, and add the exponents, because if you add 4 plus 3, that tells you how many times total you are repeating it. If you add 4 plus 1, there is really that exponent, that's going to tell how many times we're repeating that. So keep the base, add the exponent. Okay? So as we go through that, we're going to use those rules on these examples. So with this one, 5 to the 2nd power times 5, we keep our base, the number that's repeating is a 5, and we're going to add our exponents. Remember, that's really a 1, so it'll be 2 plus 1, which gives us 5 to the 3rd power. On this one, we keep our base, so that's really a c, that's what's going to repeat, and then we have add our exponents. 3 plus 5 gives me c to the 8th power. Again, if you think about this, it's just like the ones above in the fact that this is really saying 5 times 5 times 5, so that's why we're saying it's 5 to the 3rd power. This is really saying c times 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 c. So that's really 8 c's all together. Okay? You go ahead and try the got it problems. I'm not going to go through this in the video just because I don't want to make it super long. I will be putting the answer key though on Google Classroom. So if you're watching the video and you want to double check, just go back to that and you'll be able to see them. So the next set of examples looks like this, where we talked about there are coefficients in front. Okay, so if there are coefficients, you are doing that part separately. So I don't know what's up with my highlighter here. The end was like bitten off. Okay, so those parts are separately because those are coefficients. So on that, what we would do is we would say, okay, you're going to multiply your coefficients. Now, some people tend to think, okay, we add our exponents, so we add our coefficients. No. You do everything in the problem the same. The only difference is you add just the exponents, nothing else together. So then, once we have our exponents, we keep our base, add our exponents. When we simplify, that ends up being negative 3 times 4 is negative 12, and it'd be x to the 7th power. Okay? On the next example, when we're looking at it, we have coefficients again. This one is 2. Remember, if there's no number, it's really a 1, so that's like a negative 1 for our coefficient. So this one is really saying 2 times negative 1 for the coefficients. Then we keep our base, add our exponents. So when we end up simplifying that, that is negative 2y to the 9th power. Okay, once again, you have some got it problems. You try those on your own. Double check it with the notes posted on Google Classroom. Once we got through those, that's really using the idea of the multiplying rule. Most of the ones where you're multiplying will look like that on your homework. So the next part, we have y to the 5th divided by y to the 2nd. So if we want to think through what is our base, on this one what's repeating is our y's. And what is this really saying? It's really saying on the top we have y times y times y times y times y. And on the bottom we really have y times y. From there, when you think this through, before it was like we were combining them because we just kept adding more onto it. So that's why the rule is adding. When we're dividing, we're not going to combine all of them. Instead, when you have something on the top of the fraction and on the bottom of the fraction the same, they can cancel each other out. Canceling something out is like taking them away. That's like subtraction. So this is really going to end up just y to the 3rd power. The next one's very similar, except now again we have coefficients, those numbers in front of that variable. So the base is just the x because that's the part that's repeating. The 4 is not repeating each time, just the x's. So really on the top that's saying 4 times x, 9 times. Okay, on the bottom it's really 2 times x times x. So when we're looking at this again, those can simplify, but the other thing is we can simplify this part. Even though it doesn't fully cancel, those numbers can simplify. 4 divided by 2 ends up being 2. And then we can count up. We have 1, 2, 3, 4, 5, 6, 7 x's left, so x to the 7th power. So on this one, you can probably guess now, the dividing rule is keep the base. And we said when we cancel out, that's taking away, so we will subtract the exponents. So some examples to be looking at. On this one, we are going to keep our base. This one, the base is 4. We are going to subtract our exponents. When you subtract, make sure you are doing the numerator minus the denominator. If you go the other way, you will be wrong. Okay, because when we're doing problems like this, remember it was 9 on top, and it was, and I'm sorry, I accidentally wrote the wrong amount up here. I'm so sorry about that. If you were wondering what I was doing, it was only 1 here. I was accidentally writing them from the coefficient. So that's really an 8. Sorry about that. Okay, now I got that fixed. Hopefully you caught that while I was doing it and you were like, what in the world? What is she doing? But if not, sorry about that mistake. It was really to the 1st power, so you should have only been writing it once and only canceling one of them out. So these would have still been there on the top. Okay, so it would have been 8 across. So on this one, so what I was saying was, remember, it really cancels out. That's taking it away. So it ends up being 4 to the 6th power on that one. On this one, we keep our base. That base is what's going to repeat. And then we subtract our exponents. 9 minus 4 would give me 9 to the 5th power. Okay, we're going to practice that some more on the back now. But now it has coefficients to it. So just like before when we had coefficients, we take care of the coefficients first, then use that base and exponent rule. So in this case, my coefficients are 12 and 3. So when I do this problem, I'm going to go ahead and say, okay, let's do 12 divided by 3 first. Then I will keep my base, subtract my exponents. Remember, do not use that subtraction rule on anything but the exponents. So these will still go with the normal rule. So that ends up being 4p to the 4th power for the answer. If you need another one to see like that, try the got it, then check it back with the notes posted. The next example, now we have multiple ones together. So if you're going to do that, we're going to separate each one. So like here has the same base. This section has the same base. And this section has the same base. That is totally fine that it's all in one. It's like you're going to treat it as 3 separate problems, okay? So you're going to pick your first base in common and subtract the exponents. Then take your next base in common and subtract your exponents. So 5 minus 4. Then take your last set of bases in common and subtract your exponents. Remember, this is really a 1, so you'd be subtracting 1. From there, that ends up being 2 to the 3rd power times 3 times 5. And you can leave it this way, or if we want to take our calculator, you guys learned yesterday's lesson how to type this in. So 2 to the 3rd power times 3 times 3 times 5. You get 120. Okay? This one's very similar. The only difference is now you have a negative, so you would need to keep the parentheses around it. Anytime you have a negative or a fraction raised to a power, it needs those parentheses. That was part of the previous lesson. The next one, the example says Hawaii's shoreline is about 2 to the 10th power miles long. New Hampshire's shoreline is about 2 to the 7th power miles long. About how many times longer is Hawaii's shoreline than New Hampshire's? Since it says how many times longer, okay, so we were trying to find out how many times more there, we have to work backwards. If we want to know how many times something is more, we have to divide. We have to do the opposite, okay? So we're really going to do 2 to the 10th power over 2 to the 7th power to divide them so we can figure out how many times more was that then. This one has to be on the top because we're trying to compare Hawaii's to New Hampshire's. So we need Hawaii's over New Hampshire's. Since this is dividing, now we know we have to use that division rule, keep the base, subtract the exponents. That ends up being 2 to the 3rd power. I know 2 times 2 is 4 times 2 is 8, so I know it's 8 times longer. Once again, there's another example that's similar to this. You want to make sure you double check that, that you understand how to do it, because there is one homework problem that's similar to that. And then the last one. These are just examples. I wanted to make sure you understand how to do these because there are a couple homework problems like this. So all the other problems, we've been given the problem and find the answer. Now they're saying you need to find the missing exponent here. So wherever that dot is, it's missing its exponent. So like if this was here, we would have thought through, okay, take care of the coefficients, and then keep the base, add the exponents. But I don't know what this first exponent is, But we know it's going to end up being 12x to the 12th power. Well, our 3 times 4 is 12. So really, we're just looking at our exponent rule of, since we were multiplying, what plus 3 gives me 12. Okay? So it's not add these two together, it's what plus 3 would equal that 12. And so obviously, that's going to be 9. On this one, it's division rules. So really, I'm trying to think, if I keep that base there, and I say, I have to subtract what minus 2 gives me that exponent of 4. So what would I use to take away 2 from to end up with 4? That would be 6. Again, I have people that think, okay, it's subtraction, so I do 4 minus 2. No, 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 no. You're trying to decide, what did I take away from 2 to get 4? Or I'm sorry, what did I take 2 away from to get 4 on that one? Okay? Hopefully that was helpful. If you have questions, because this is kind of a tricky lesson, make sure to let me know, and I will do what I can to help you.